All right, today we've got a really cool story from the front lines of AI. It's a classic David versus Goliath tale, where a tiny, specialized tool is going head-to-head with some of the biggest names in tech. And that brings us to the big question, right? How in the world can an AI model that's over 1,000 times smaller than its competitors manage to keep up, let alone actually beat them? It sounds kind of impossible, but as you're about to see, bigger isn't always better. So to really get what's going on, you first have to understand the problem they're trying to solve. I mean, our entire world runs on documents, contracts, reports, you name it. But for an AI, all that information is basically trapped, locked away inside these static images and PDFs. It's unreadable, unstructured data. And look, we're not just talking about reading a simple line of text here. No way. The real challenge is getting an AI to make sense of the wild variety of documents we use every day. We're talking about everything from messy handwriting and complicated legal forms to scientific papers packed with tables or even multi-column articles from old archives. It's a huge, huge hurdle. So, what's been the industry's solution so far? Well, for the past few years, the whole philosophy has been pretty simple. Bigger is better. And that's led us straight into the age of the AI giants. Yeah, the go-to strategy has been to build these absolutely enormous do-it-all models called vision language models, or VLMs. The idea is, if you just make a model big enough and feed it enough data, it should be able to learn pretty much anything, including how to read these tricky documents. And when I say massive, I am not kidding. A major VLM from one of the tech giants can have something like 72 billion parameters. You can think of parameters as the little dials and knobs an AI uses to learn. So, yeah, that number just gives you a sense of the colossal skill we're dealing with. But what if that's not the only way? What if there's a smarter, more focused approach? And that's where our challenger, PaddleOCR 3.0, steps into the ring. So get this, instead of billions with a B, the models in this PaddleOCR toolkit have less than 100 million parameters. No, that is not a typo. We're talking about a model that is hundreds, sometimes even more than 1,000 times smaller. Okay, let's just break this down side by side because the difference is wild. On one side, you have the giants, billions of parameters built to do everything and often locked behind a corporate wall. And on the other side, you have PaddleOCR, incredibly lightweight, built for one specific job, being a document specialist, and it's totally open source. It really is that classic matchup, the versatile, powerful heavyweight versus the quick, nimble specialist. But the real question is, can the little guy actually land a winning punch? Before we see the results, let's quickly talk about how we're keeping score. We're going to look at a metric called one edit dist. All you really need to know is it measures how accurate the text recognition is. The closer the score gets to 1, the better the model performed. Simple as that. And the result is, well, it's pretty stunning. The tiny PP-OCRv5 with only 70 million parameters scores a 0.804. That is higher than the 72 billion parameter Qwen model, and it's way better than both Gemini and GPT-4o. The lightweight specialist doesn't just hold its own, it actually wins. So how is that even possible? Well, PaddleOCR's secret weapon isn't just one model. It's a whole toolkit of 3 highly specialized components that work together perfectly, each one designed to do a specific part of the job. So the first tool is that winner we just saw, PP-OCRv5. Think of this as the universal reader. Its whole reason for being is to do one thing and do it exceptionally well. Find and read text with incredible accuracy. It doesn't matter if it's printed, handwritten, or even in ancient scripts across a bunch of different languages. But just reading the words is only half the battle. That's where tool number 2 comes in, PP-StructureV3, the document architect. This thing is brilliant. It goes way beyond the text to understand the document's actual layout, the columns, the tables, the charts. It basically takes the visual page apart and puts it back together in a logical, structured way that a computer can finally understand. And when you look at how well it parses those really complex layouts, well, the results tell a very familiar story. The specialized PP-StructureV3 once again hits state-of-the-art performance, leaving the big generalist giants behind. The specialist approach just keeps on winning. And that brings us to the final tool in the kit, PP-ChatOCRv4, the information extractor. This is where it all comes together. It takes that perfectly structured data from the document architect, uses a language model to understand what you're asking, and then zips through the document to find and pull out the exact answer. It basically turns a flat static image into a searchable, interactive knowledge base you can talk to. And yep, once again, the numbers don't lie. Here we're looking at a score called recall, which is just a fancy way of saying how often did it find the right answer. PP-ChatOCRv4 nails it, over 85% of the time, beating out the massive Quen model and GPT-4o. It's a clean sweep. But you know, this incredible performance isn't even the whole story. What really matters here, the real game changer, is that this kind of power isn't locked away in some corporate lab. It's about putting these tools directly into the hands of developers and creators. This entire toolkit is open source. It's free. It's designed to be super easy to use. It has flexible options so you can run it on anything from a phone to a giant server. And it's backed by this massive community. We're talking over 50,000 stars on GitHub. So this isn't just better technology, it's accessible technology. You know, the researchers who built this summed it all up perfectly in their report. They said, lightweight models specifically designed for OCR tasks can match or even exceed the accuracy of large-scale multimodal models. And that's really the core thesis of this whole story. And that leaves us with a really fascinating question to think about. We've seen it happen here, in the world of document AI, but could this be a sign of a much bigger trend? In the future of AI, are we going to see these focused, specialized Davids consistently outperforming the massive do-it-all Goliaths? Only time will tell, but it's definitely something to watch. Thanks for tuning in.